So just title of this is backend, just performance and error monitoring with APItoolkit. So okay, so I think everything is working well. So and I would be talking about why the modern observability tooling that we have is not enough, and what we're doing about this problem. So my name is Anthony Elibia, like I said before. So I used to be a staff software engineer at Delivery Hero here in Berlin, in Germany, and have been kind of all over the place, just building software for different places, like the US Police or and yeah, the why APItoolkit as a company exists right now is due to my time at Delivery Hero, where I led some migrations of API services that didn't go quite well, and where we lost over $2 million worth of orders. I would tell you that story actually. Um, Actually, this story, yeah, this is a picture of Delivery Hero in Berlin. So this is the office I worked out of, and the story is basically that in 2019, so 5 years ago, I led this rewrite of a service of a legacy system. We're trying to write it in Go for performance purposes. Mainly because the systems that we had already were hitting the limits of the traffic the company was handling at the time. So the company was growing and acquiring more food delivery brands around the world, and just couldn't handle the traffic. So I came in and I was going to lead efforts of writing just one, the search and discovery experience, which is if you think of a food delivery application as a funnel, it's the larger part of the funnel because people are going to have to find their dishes before they can order it or have it delivered to them. So we had to build this search and discovery experience, and we wrote it in Go. So we were pretty careful, as careful as you would want to be in a company like this where a lot can go wrong. We tested the systems as much as we could. We 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 had a very ingenious way of building this where the new system would be a proxy to the old system, and we would progressively uh, enable new functionality in the new system and have that override the traffic that's so the traffic doesn't go to the old system and is handled completely on the new one. But all the other functionality which we don't care about can continue going to the old one. And for this task, we wrote some logic where when like if you try to load the lists experience, our new system would perform its logic as usual, but would also make a request to the legacy system and try to diff the request to see if they are exactly the same because we wanted to do a drop-in rewrite. And we had this running in staging for 2 months. We did all the testing we could do, manual diffing we could do. But when we rolled this out in production, of course, things broke. If things didn't break, then this is likely not would not have happened. We lost, we lost a lot of orders, and I had to write a postmortem, trying to figure out what we could have done wrong, better, what was the issue, and what we could have done better. Of course, we immediately we detected this. We had rolled back, so the issue was more about the bug. Like how could we have implemented this rewrite in such a way that we we would have caught that breaking change. So the bug or the issue that we introduced was that this was a food delivery brand operating in over 50 something countries. So in most of these countries, we tested in a few of these countries on staging, which were especially the countries where we had engineering offices in. But yeah, the bug was only coming from a few countries, mainly Scandinavian countries, because in Scandinavia they had this legal requirement that food brands have to return the dietary details and that's the allergens and all this kind of information of the dish. Basically, one field in the response was missing. So it was a 200, there was no downtime, but one field was missing in these APIs. And all the observability tools we had Datadog, we had New Relic, and we had a build that was running in millions of euros, or at least over 1 million euros on this observability. But even with this huge expense, uh, why could none of these observability tools catch that issue? And this is not unique to me. Systems in the industry are not that stable, and and yeah, it frustrates everyone. And you can see that the how the instability of systems in the industry um, is noticed. And if you do a quick search on Twitter, you would see different people complaining about all kinds of stuff. Like these girls said, I figured out why all my tests are broken today. Apparently, development decided to change the syntax for the entire API as part of a bug fix and didn't mention it to me. So breaking changes, poor documentation. Not really poor documentation, but usually that the implementation goes out of date from what was documented. And this is not unique to the small companies. You see big companies like Notion, etc. Uh, yeah, are just as bad. So now let's come back to what we want to talk about in this talk. I want to talk about modern observability and what it is. So there are three main pillars of modern observability. The first is metrics, and the point of metrics is that you can detect when something goes wrong. And if you think of your systems, or let me give an example of what a metric would be. So let's say you have a server and you're tracking your CPU as a number. So CPU percentage, maybe at 1 second, at this particular instance, the CPU is 50%. At the next instance, the CPU is 100%. So each of those are metric points. And if you aggregate them, you can, uh, you can set, for example, a threshold or set an alert that says if my CPU goes above 90 or goes above 50, send me an email or notify the team. So metrics are very good at catching those kind of problems that can be measured, and you can set alerts on. The second pillar of observability is traces, and traces help you pinpoint an issue. And traces were not really a pillar of observability until fairly recently. Uh, so if you go back to 20 years ago, they were. I mean, of course, traces was still a thing, but it wasn't as popular as it is now. When you gather traces, it's a lot of data. You start to worry about the storage of this data. And that's why you see a lot of observability platforms that collect traces, but then they tell you we're going to hold it only for 24 hours, just because it's really a lot of data to track. But the advantage of traces is when you're troubleshooting, and especially if you're building, if you exist in this kind of heavy microservice oriented architecture, since you would be able to follow a customer's request or a customer's behavior from the entry point into your infrastructure and see which of the microservices it encountered along the way and which of them actually had the problem. But you can, depending on how you set up these traces, you can even zoom in on one particular service to answer a question like, um, within this particular service, what function, what are all the function calls that my request had to pass through, and which of these functions had a problem, which of them was slow, which of them had an error, for example. But the challenge with traces is that it's really it's not very easy to instrument. You end up littering your code with so many of these debug lines, and again, you gather so much of this data, that it's hard to store because it grows large so fast. But we're humans, we can't analyze all that data. So it ends up being more or less useless, to be honest, because it's too much data to go through. Logs is the third pillar of the modern observability stack. And the point is supposed to be that we pinpoint what is causing the problem, which sounds simple in, in, or we would like it to be simple, but in practice, it's not that simple. Give me 1 second. I'm trying to make sure we have, yeah. So in practice, this is not that simple. And why it's not that simple uh, is because logs require the engineer to either log everything, so you log everything and then the logs are no longer useful at all, or you predict the future. I'm not very good at predicting the future, but some people are. So where you predict what are the things that are going to go wrong along the way. What what can I what can I log? What information should I send out to standard output that would be useful when that issue happens? So this is very good. Unfortunately, a lot of issues that happen, we only know it's going to happen after it has happened. So yeah, logs end up not being enough, and then logs, just like traces, they end up being too much. So you are bombarded by too much detail, which as a human we also can't analyze all that data. It's just too much data to analyze in a short time. So has this been enough? Hi everyone. Hi Frank. Hi David. So those are people on LinkedIn. So has this observability been enough? Now that is a question I would like to answer with no, because I think if this was enough, we would not have that issue that I told you that made me build a APItoolkit in the first place, where we have logs, you have metrics, you have traces, you have all of this stuff, but things still break. And when these things break, none of these observability tools even know that something broke. And what I've settled on is that there are two kinds of things that can go wrong in a system. One is issues that are related to infrastructure. So, for example, you have 100% CPU, and so your server can't handle traffic anymore as a result. Or you have your database goes down, or database overloaded, and now your app can't handle. So, this kind of situations where things really would go down and your app is, you know, gonna return a 400 or 500 because it just can't work anymore. The existing observability are very good at surfacing those kind of issues and letting everyone know that, oh, your database is down, or we have a high error rate because something is no longer working. But there's the second class of problems, which is of reasons why applications I want to say due to user bugs or user mistakes, or issues along the dependency tree. And that is, for example, you have an endpoint that is supposed to return the list of users, and it always returns the list of users. But all of a sudden, it's returning an empty list. It's still a 200, but the list is empty. That is a bug. Something is wrong, but none of these observability tools will tell you. Or let's say you have an endpoint that returns one single user, and for a user to be valid, you need to have the user ID in place. And this user ID is part of your open API specification. But all of a sudden, uh, um, was involved with some company where this happened, a fintech company, where they had a very, very painful bug where they were no longer, for new users, they would no longer return the user. They kind of have this kind of ID. It's not really an ID, but that it's a value that is used in generating a QR code for the user, and that's how the user is able to receive money and stuff. and it was a painful bug because existing users it would work very fine for them. This was only an issue with new users, and when a new user complains that, oh, I'm having this issue, the engineering team will go and try to reproduce, and they will see the ID and the QR code, and so they're like, "Is this user lying to us or what?" Because they just could not reproduce the issue until they figured out, oh, we actually have to create a new user to reproduce the issue. So this kind of bugs exist, and why can't our observability tools catch it? So most observability we have right now are focused on the first category, which is tools that we know right now came from that world. It came from monitoring infrastructure, core infrastructure, and not really about the application itself. But we're no longer in 20 years ago. We actually are writing no code now, and it matters that our application actually does what it's supposed to do. In the past, you would have these 6 months release cycles where you would build software. It would You would have 6 months to test it, fix things up before you release it. Infrastructure monitoring was usually enough because most of the bugs you're facing are not coming from bugs in your code, but are coming from other systems. So, what are the common API challenges that we would face as developers? So, one category would be, I think I spoke about this, like usability issues, but also documentation issues, and that's situations where like the sandbox and the production are pretty different. Um, this enterprise integration is, that this is a pain. I had a situation where we spent a couple months implementing an integration. And when we had finished, we were like, yeah, finally, time to roll this out in production. We put all the API keys and stuff. We now enable it in production and find that it's not working. We reach out to the engineering team, telling them, hey, like, what's up? And they say, oh, the documentation we gave to use for just our sandbox, and that sandbox is not yet live. But in any case, it's very common that our application strongly deviates from the documentation we have to represent it. And another group of issues would be, fields that are missing or fields that are in the docs but are no longer being returned from the APIs, or not having a change log to track what has broken, what has changed over time, so that your customers can, or even the engineers in the company can track whatever is going on. Another group and a very big group of issues is just performance issues. So where you have latency problems or rate limiting, handling data correctly. Lots of timeouts, things break, things are slow. So these are common, and I actually argue that these kind of issues, there's so many tools that exist. For example, the existing forms of observability are optimized for solving these problems, this kind of performance problem, because they come from this world of infrastructure monitoring. And then another group would be these reliability concerns, error handling, tracking what errors and what issues are happening in the backend, API inconsistency, where one engineer in the team is using camel case, another is using snake case, just lack of consistency within a company. And the most important, these breaking changes. I actually debugged an incident in the past where there was this field, this endpoint that would return a date. Yes, one of the fields, there would be a date field. And we were using a library. I won't name the library, but it's in the Go ecosystem. And this library would pick a default. It had this default hierarchy for how it would render time. And I think it defaulted to the US date time, and people in the community were not very happy about this and were very vocal about that. So eventually, the developers behind the library decided to switch to the global date format, which is a good thing. and they created this uh 6 months period, where they were like letting everyone know that this is gonna be changed. But unfortunately, we don't read I don't read GitHub issues of every library that I use. So one day, working on something, someone updates the library, pushes to production, and everything breaks. And it's the worst kind of breakage, because if you look at it, you need to look at a date that is like 30th of January or something, uh, before you can know that there is a bug. Because if you look at 1st of January, it's the same in both the US format and the global format. So other issues would be like this kind of security risk and this kind of problems. So I don't want to focus on this too much. So let me just quickly show you what API Toolkit is. So I mentioned a lot of problems, but API Toolkit is actually exists to try to solve these problems. Um, one second. Let me see if there's any question I should be responding to. No, I don't think there's any question I should be. Okay. Oh, someone said my voice is faint. Oh, I don't know. I have no idea. I should have done like a proper check. Okay, so the voice is faint. Maybe I just bring this closer to my mouth. I bring the microphone closer to the mouth. So I hope everyone can hear me. So I'll just show what API Toolkit is, and so I mentioned this story at Delivery Hero, right, where we had breaking changes that made us lose a lot of money. And so what API Toolkit is it's it's an SDK you integrate into your backend, and it's really focused on backends. So you will not use API Toolkit to monitor your Kubernetes, for example, but you would use it to monitor the application that is running inside that Kubernetes cluster. So there's an SDK, and it basically copies the API request that your request to third-party APIs. It's also, of course, copying and recording the request you're making to those third-party APIs. So we flatten, these APIs and build a maker tree out of it, and which we're able to use in catching breaking changes. And that's kind of what sets us apart from Datadog or anybody else in the industry, that we're able to catch these breaking changes. But of course, because we are logging the API request, it means if there's a bug, you can search for what your customers were doing. And we also track the errors. If there's any runtime exception that happened while you were processing a request, we also track these errors, as well as any other like logs. We're working on adding support for general logs and traces. So you have everything you need to debug you can create these synthetic monitors where you say, hit this endpoint, maybe hit the login endpoint, then use that data to hit this other endpoint and accept that these values are whatever you want. So it's basically passive monitoring. That's with the logs, and but also active monitoring, which are these synthetic monitors and synthetic API tests. So the core is, catching breaking changes. So being able to tell you that, hey, we noticed 12 fields were updated in this endpoint, or 5 fields were deleted in this endpoint. But like I said, we're also tracking all the errors in your code. So that would be this type error being like an error that is coming out of the code, maybe a backend error, as well as maybe API changes that might not be a breaking change. For example, two new fields. It's not as bad as fields that were deleted or updated. Of course, runtime exceptions is also like code that is error that is coming from your backend, and that check. For example, this monitor says, okay, if there are requests errors that are requests where the error is or the method is patch and the status code is not 302, then trigger this alerts. So that's basically that's the core, and these are the kind of issues you worry about in a company. And when we catch breaking changes, we show you the list of the fields that were new and and the platform is logging all the requests that come in and out, and that, basically logging everything, including the body, which means you can filter and search based on whatever is inside this payloads. So, for example, you can expand it and you see what is in the response body, and you can search by whatever is inside this response body. And if there was an exception, like a runtime code, on top of showing you all the you know request body and response body, you are also able to see all the exceptions and errors that happened while we were processing that code. I hope people can still hear me. I know I could I could probably have made this a bit louder, but please ask questions that you have. And of course, you can copy the request that had an issue as a call, which you can import into Postman or even just run it from your terminal if you like running call directly. Um, of course, API toolkit is also an APM. Performance indicators like your throughput, that's request by status code, or throughput by status code. See the latency, that's the how fast or how slow your endpoint is. P90 means that 90% of requests are handled in less than 700 milliseconds here, but 75% of requests are handled around 200 milliseconds. So this is a pretty good server. Uh, you can see that we get up to 700 errors out of 10,000, and you can see that which endpoints get the most traffic, for example. And this same analytics that you see, you also can get it for, because we are automatically detecting all the endpoints, and we know the payloads, we know everything that's going on in your backend. You can see all the endpoints at a glance, and then dive into any of the endpoints to get those same metrics and those same numbers, but just specific to that endpoint. And everything I showed you right now, you can do it not just for your own backend, but if you are depending on third-party API integrations, you are able to, basically get this as well. Let me bring this down so you can see. Okay, that's something happened. Okay, and that everything's working. Okay, so we now have access for the synthetic monitors, which I mentioned, where you can write these tests and that basically make use of your APIs and assert that certain values and certain things or certain endpoints are behaving the way you want. And this would get expanded in the future such that the first monitors or the first API test can be detected automatically and generated automatically for you. So this is kind of an application of LLMs to API monitoring. And of course, we were able to generate open API. I mean, with the kind of understanding we have of a backend, the API, open API swagger you get from API Toolkit is pretty detailed in a sense that you would have, uh, for example, the fields, the regex that represent each of the fields in your backend. So last thing I want to talk about is if how we handle confidential and sensitive data. So you can define fields that you consider to be confidential, and those fields are automatically redacted out of your server. So you don't really have to. Yeah. So I think I should position myself in the center properly for this camera. Okay, and then yeah, you can also there's an enterprise option where you can host API toolkit on your own servers instead of using the cloud service, and we help to manage this. But this is, to be honest, for most people, it's easier to just be in the cloud. But with the cloud option, you probably, especially if you feel like you don't want to trust open some observability platform with your data, and how we compare to existing platforms. It's in the market, right? So everyone has their own focus, and we have our own subsets. For example, what we do, very few people are able to do this as well in the market, and that is catching breaking changes in your APIs, and correlating your API issues with any runtime errors and all the context an engineer would need to debug problems. So we're basically a complete API lifecycle management, in a sense that we're tracking the incoming requests, but also outgoing requests to third-party dependencies, and then yeah, we're monitoring the APIs in real time and catching anything that changes or anything that breaks. Uh, of course, we're kind of like Sentry and Rollbar. We're like an error aggregating platform, just that we go beyond just regular runtime errors, but we have runtime error tracking, but also track breaking changes in these APIs. And um, yeah, I think I've spoken about most of this already. And now we're working on this test generation where we're able to generate those tests and those synthetic monitors automatically based on how we understand your customer behavior on your APIs. But yeah, that's kind of API toolkit and our subset of the world of monitoring. So I would like to answer any questions that might come up. So Kenichuku asks a question: does API Toolkit help track security vulnerabilities on monitoring endpoints? So these are two separate questions. The first question is if we track security vulnerabilities like OWASP, where we this is a topic that is the API Toolkit for security conversation is kind of still ongoing. At the moment, we are looking out for some of the simpler vulnerabilities like SQL injection or incorrect use of, for example, JWT tokens. But this is still in the early stage, and it's like a checklist, and we're increasing the number of things that we're checking in this checklist to make sure that if you're using API Toolkit, if your engineers do something that might put you in trouble, that we should be able to, at the very least, notify the team that, okay, this is something that you want to do, something you want to change or improve. The second question is, how does it update the documentation when there is a change? I had a slide that explained how we actually even catch breaking changes. Let me go back there. I think somewhere here. Yeah, actually this page. But we have some very interesting implementation, leveraging some nice concepts from cryptography. So basically, MecoTrace, And when there's a breaking change, we have some more things that we are doing. But basically, API Toolkit is constantly learning from the traffic, which means we have a model that represents your entire backend. And after your engineers, so anytime we notice a breaking change, we send a Slack, email, etc., to the engineering team, telling them we've noticed this change, and we expect the engineering team to either acknowledge the change, which tells us that okay, this change should be part of the specification. This is something the team actually wanted to do, and if they acknowledge it, then we just uh, uh, add it into our model, and from the platform you're able to generate this specification with no problem. uh, and that's I can show you. Sorry, I should um, yeah. So that would usually look like this. So if you go into this Open API part of the system, it takes a second when we're generating. Let's use this one. Yeah, exactly. So just when you go in here, you would immediately just get see, yeah, the specification right in there that was generated based on the request that we had to handle. I don't know if that answered your two questions, Kenichiko. Does anyone else have a question? And those were good questions. Thanks for asking. Mm, Ahmad says he loves the work. Thanks, Ahmad, on YouTube. So let's see if anyone has any questions. But if there are no questions, this is kind of what the platform is. And yeah, I would like to hear what you think. And if you get to give it a try, yeah, just let me know. If you hate it, also let me know. Okay, so let me wait a few minutes to see if anyone other than Kenichiko has a question. But otherwise, then we can, call it a day. I had fun, talking about this. Okay. So everyone, thanks for showing up today, and yeah, have a lovely time ahead. Okay. Oh, I have one more question. I just answered this. How many of these features are available on the free version? Everything is we process 20,000 requests per month for free, and that's 5,000 requests every week for free. And things like synthetic monitors, you're kind of limited to creating monitors that run once a day as opposed to every minute or every second, if you like. Um, yeah, so thanks everyone, and yeah, enjoy the rest of your weekend. Take care.